Hello, everyone, and welcome to today's webinar presented by GigaOm. My name is Ned Bellavance, and I am really excited for today's topic. We are going to be talking about evaluating edge computing. If you haven't heard about what's going on at the edge, now's your opportunity to learn more and maybe discover some mistakes that you'd like to avoid when you're planning out your edge deployment. As I said, my name is Ned Bellavance. I am an analyst at GigaOm, and my guest today is Dave Demlow. He is the VP of Product Management at Scale Computing. Welcome to the webinar, Dave. How are you doing today?
I am doing great. Thanks for having me, Ned. And thanks for everyone attending.
Yeah, awesome. Yes, thank you for everyone attending. I know it's kind of a crazy time right now, so I'm glad that you were able to take a moment out of your day to listen to us talk about something that I think is kind of important. Dave, if you could just set the stage for people a little bit, what's your, briefly, what's your background? Who are you? What do you do?
Sure. I work for Scale Computing. I've been with the company over 9 years. And for those not familiar with Scale, we're a leader in hyperconverged simplified infrastructure. So combining compute resources, storage resources into a very, very easy to manage, self-resilient, self-running system. And that has everything built in. So all software is basically delivered as an appliance generally, easy to load up, manage, run applications, and let IT staff focus on more important things, such as enabling new applications that are driving new business functions.
Right, right. Delivering that value to the business, which is the whole reason like IT people like us have jobs.
Exactly.
That's a pretty good thing. Well, the things that we're going to be covering today in the realm of edge computing is, as I mentioned, this four mistakes you want to avoid, and we're putting this in, four different buckets. One's the aspect of complexity versus simplicity. A look at what traditional approaches might be for infrastructure versus what you need to do at the edge. Minimizing downtime, which sounds pretty obvious, but there's some nuances there that we want to get into. And how do you manage an edge solution? What's some pitfalls to avoid there? And then we'll have an open Q&A at the end, but please feel free to submit your questions at any time. We'll take a look and answer your questions at the end of each of these categories. Before we dive into those categories, I think it would be good to level set a little bit what we're talking about when we're talking about edge computing before we dive into these individual characteristics. So Dave, when we're talking about edge computing, sort of can you drill down a little bit into what we actually mean by that? Because I know there's there's a lot of different edge marketing out there, so it's good to
Sure.
put some bounds around this.
Yeah, and right there's lots of things. Scale in general, we actually take a pretty broad view of edge, and our kind of highest level definition would be any this is the place anytime you're running mission critical applications, IT applications, out of a centralized data center. So where you don't have IT staff that they can range everything from regional offices that maybe a half a day's drives away. Those are pretty traditional remote office, branch office. They can be ocean-going vessels that have IT resources and needs that very sporadic connectivity that need access to plans for ocean drilling rigs and things like that, to retail locations that need to be able to operate autonomously without internet connections, and without obviously IT staff being on site to manage and monitor or even replace failed parts. So those are kind of the wide range of applications that we actually have customers in all of those kinds of different use cases.
Okay, yeah, I can definitely associate with the retail case because I worked retail help desk for
Yeah.
almost 2 years, and the technical competency at the store level was widely varied. I had to explain what a printer cable was once to a lovely person who had never touched a computer aside from typing in numbers on the register, and it was just that's what you're dealing with at these edge locations, and you
Right.
need to be able to manage that level of difficulty with your edge solution.
Yep.
So let's dive into the first topic, which is complexity is the enemy. And if I could sort of paint a picture of what I'm thinking when I think of complexity being a challenge is you can cobble together a solution for your edge computing needs from a bunch of different open source components. You can buy your own hardware. But the factor that, what I think of as the biggest cost is not so much all the money you're saving on not spending the money for a managed solution. It's all the money that you're going to be spending on your IT staff when they need to roll out to a location or, administer this behemoth or this Rube Goldberg machine type solution you put together. Dave, what have you seen in the field, and why is complexity such an important thing to avoid for edge computing?
Sure. Well, yeah, ultimately, the more complexity you have, the more things to break, the more things to monitor, the more things to update, the more things to go wrong. And I'm sure we'll talk a lot more about, specific examples of those. Complexity, is also the more things you have, the more different pieces, the harder it is to secure, the harder it is, everything just becomes more difficult. And, in some of our more successful edge deployments, complexity was actually the number one thing they set out to solve. So, they specifically wanted to go from maybe an environment where they had, a bunch of different networking appliances, a one physical server for each, critical application, and its own software stack, sometimes its own support organization just that cared about that one application, to a consolidated architecture that could run multiple applications, could be monitored and managed and patched independently, that separately also adjust high availability needs, that had built-in resiliency, redundancy, so that when something did go wrong, which is to be expected, hard drive fail, servers fail, power supplies fail, software patching has issues, that it wasn't a fire drill, and they didn't have to, immediately roll people out to troubleshoot, correct, and resume operations. Complexity really is kind of the key to a whole bunch of benefits and solutions.
Right. When you're going to these customer sites and sort of seeing what they've cobbled together, is it generally consistent across all the different locations, or are you seeing a lot of variability of the same intended solution across a bunch of different locations for a customer?
Well, yeah, I mean, there's a lot of variability even within single customers, but certainly across customers. Yeah, we see a lot of different legacy. I mean, some common themes, in terms of uh, whether they've adopted virtualization, for example, or not. A lot of these edge deployments, like I said, are, hey, we had this new application, we bought a box, we loaded an operating system on it, we loaded the software, and now we have this accumulation of various boxes, appliances, networking layers to manage. So that's a pretty common theme at those kinds of levels. There's also, again, larger environments. I mean, not edge. Edge doesn't always mean small, is kind of one of the other things that's worth talking about. We do offer some very low cost edge devices that include high availability, and that's important for a lot of segments. But edge very often is very large in terms of compute resources, data storage. I mean, something like video surveillance analytics is a perfect example of that, where there's a great amount of data being collected and a great amount of compute resources that are needed on premises close to where that data is created, as opposed to sending things back to a central corporate data center or cloud. So there are a really wide range of use cases that we see that fall under the edge umbrella.
Yeah, but I think a common theme that I would spread across all of them is just like any technology stack, the more complicated you make it, the harder it is to manage. Is is there something about edge solutions in particular that complexity gets exacerbated by the fact that it is an edge solution?
Yeah, I mean, generally, again, not having IT people on site, it's not as easy to walk to an aisle and look at a rack and see blinky lights and things like that. So the ability to remotely troubleshoot becomes critical. Even better is the ability for your infrastructure and your applications to automatically have resiliency. So when something goes wrong, say on a server, that there's automatically redundant equipment available, and a system that will take care of and autonomously keep the application up and running on what's available. But so there's certainly things like that that you can look for. But the biggest difference there again in Edge is generally nobody's there. There's lots of locations, or many locations, and that just depends on the organization. It could be 10 locations that are remotely managed. It could be 100. We have customers that are in the thousands of locations that
Hmm.
need to be centrally managed as well.
Right. So if something goes wrong at 100 of those 1,000 locations, rolling a truck out to each one is that could be a little expensive.
That could be a little expensive, a little time consuming, and yeah, and usually to the point of impossible. So you're actually paying service companies to stand on call or have parts of depots or repositories and things like that to be able to address that inevitable hardware failure that will require you to roll a truck out there.
Right. So I think we've hammered home the complexity point. I do have a poll because I'm curious for people out there what level they're currently at when it comes to their edge planning process. So I believe our host is going to put up a poll for those who are viewing to answer. And I'm just curious, how would you describe your current edge planning? Are you investigating options? You're still at the not sure if edge is something we even need to dive into. Are you testing a solution in development, maybe at the cubicle next to you or something? Have you deployed a pilot of it to a number of locations to see if it's viable? Are you running it in production, or just none of the above? Edge is like, which I'm not sure why you'd be on the webinar, but that's if it's none of the above, it's none of the above. I understand that too. So, Dave, what if you had to guess, if you were looking out at the landscape, where do you think most organizations are in terms of their level of edge planning at this point?
Yeah, well, we definitely are working with a large number of customers that are investigating, many that are at pilot stage, as well as, I mean, we have many customers in large scale productions that are rolling out multiple sites a day, and in an ongoing basis, and working up to the thousands. Obviously, I think if you're in those more mature phases, you're probably not on this webinar because you're uh, already well down that path. So
Yeah, no, that makes sense to me. Yeah, I think you're right. A lot of people are probably at that planning stage, but it looks like the poll just closed. So let's see what the results came in
yeah,
as. I think our webinar host is posting them into the chat. So
yeah.
45% are currently investigating options. How does that strike you, Dave?
No, that's good. Then they're in the right place. That's hopefully we'll give them some good things to consider and think about. So looks like
Okay.
18% are testing and development, so they have some at least initial architecture that they're evaluating. 9% running in production.
All right. And none of the above, 27%. So a lot of people, I guess, are just at the pure, I'm thinking about it phase.
Well,
I'm
yeah, and
curious. I want to know more.
they're still in the market. There's still a lot of, hey, what is this edge stuff that I keep hearing about, and why should I care, and how will it impact me? And so hopefully those people will learn some as well. So eventually, it depends. In many businesses, there's going to be more and more things that are not applicable to run in a public cloud or run in the central data center that are new applications are going to require large amounts of data and processing close to where that data is generated, and that's coming
Yeah,
across in a lot of verticals, a lot of different applications and use cases.
I think we're all tired of the digital transformation mantra, but it is real, and I guess edge transformation might be the next phase of that.
Yeah.
Um, Dave, you just mentioned data centers, and I think for a lot of us, we're fairly good at understanding how to manage a data center. A lot of I personally come from an infrastructure background. I'm familiar with sort of the lights out capabilities, but also walking up to a rack and popping out a server and troubleshooting it. That's an approach that works really well for a centralized data center, but I imagine, in your opinion, it probably doesn't make as much sense for an edge computing solution.
No, and right. Obviously, the exact equivalent. There's no, unless you're going to, drive out to all these locations on a regular basis, there's obviously the requirement for remote monitoring, and even beyond that, for assuming these are mission critical applications that you care about running, these sites actually need autonomous operations. So when something does go bad, they can't rely on either a network connectivity to be up and go back to some central brain and make some decisions or take action, or a human at a central location to be able to have visibility into that site, take some action. There's absolutely a need for local intelligence, local self-healing. Our particular software stack, we've invested a lot in monitoring, these multiple, what we call nodes, edge compute nodes that are, servers running applications, providing storage, monitoring everything that's going on with those in the environment. And I guess another big difference is these environments are different. They're not going to be, in most cases, they're not going to necessarily be well cooled, and often are in, rugged environments with wide temperature swings, things like that. Often there are, different physical constraints. These are the kinds of, as an example, these are kinds of things you might see, that are under a counter in a quick serve restaurant that, are running the store and running transactions, or in a retail store, might be in a little, telco like rack that has all the gear rolled up to the ceiling and out of physical access, that are, sitting there providing critical services that keep transactions going, keep business critical applications going, that need to be able to operate and take automated actions on the applications and infrastructure without a human there, without a human necessarily remotely having access even, and without resulting in downtime, most importantly.
Yeah, it
Sounds
makes
easy.
me think. It makes me think of I did a project once where it was replacing network gear at a chain of fast food restaurants, and going in and seeing the conditions in which this equipment had to run was quite eye-opening. And oftentimes, just being able to get to the equipment, like you were describing, you're not going to have a nice air-cooled rack that's in its own designated space with its own, locked cage. Climbing up on shelves behind the big box of Solo cups to get to this switch, right? It's an interesting world out there. Um, so physical security is not guaranteed for these devices, and I think another big aspect of it is the way that you connect them from a networking standpoint and provide them storage. You don't have a big SAN, you don't have a core switch, you don't have a locked cage. What are some ways that you would approach the needs to have good storage and some level of physical security and networking uh, for these edge computing locations?
Sure. Yeah. Well, so obviously our infrastructure, because we're based on a hyperconverged infrastructure, we can provide a cluster of small, inexpensive devices that all provide compute, storage, have access to the network, that collectively run run your pool of applications, make sure that those keep up and running, even as components in those systems fail. So that's a key aspect. Often what we do see is customers use virtual networking, whether those may run as virtual appliances, virtual machines, right on as an application that provides network ingress and egress control policies, things like that. Sometimes that's done in a smart switch or firewall that's providing those applications, basically doing the same thing. But many of our customers do go the next step, and actually that's one more box, one more appliance, a physical device that they can take out of the branches of the remote edge locations and run on the common infrastructure. In terms of physical security, I mean, I think that's important regardless. So, we do generally see these still, even though you're not going to have a cooled, temperature controlled data center. We generally do see these at least being physically secured in some sort of, lockable, rack device cranked up to the ceiling, those types of things. Certainly securing, network ports physically and so forth. Yeah, I mean, you can't, allow for some of these devices are very small too, by the way. I mean, we're not really going into some of the hardware here, but, we run on we have systems that run obviously 1U rack pizza box type formats. Some of those are half depth that will run in telco style racks as well. We also recently introduced an entry level line of devices that are very targeted for edge. that are about 4-inch by 4-inch cubes. If you've seen Intel NUC devices, that kind of size, or things that would be a small desktop class of device as well. That in these edge environments can be clustered together. Put into a locked cabinet or things like that, out of the way, and definitely are easier to more physically secure than, a bunch of tower PCs or things like that we often see, under a manager's desk, for example.
Sure. And from the storage aspect, like, because you don't have a SAN, but you still need some sort of redundancy. Is there a solution that you typically see for edge computing around storage?
Well, yes. So in our HC3 infrastructure, every node in our system provides storage. All the data is, they're clustered together. All the data is distributed redundantly. So, any bit of data that you or your applications create are distributed across multiple drives and multiple nodes. So if a system dies, a drive dies, it's actually not a fire drill. You just let it go. The cluster self-heals, continues running the applications. As a matter of fact, we have customers who have over provisioned enough compute and storage capacity that they're designed to even let multiple failures occur over time, and maybe once a quarter or once a month, depending on the location, they go out and they repair. All right, well, this site had 5 hard drives fail, or this many SSD drives fail, this many physical nodes, and they go out and kind of all at once make that trip and kind of regenerate the capacity. But from an availability standpoint, they didn't have to rush somebody out there same day or even next day to take care of those. So, and it just depends on the cost of the environment. If these are ocean-going ships, where which we literally have, where it's like if they need replacement parts, that often is either wait days or weeks till they get to the next port, or a very expensive helicopter trip to deliver
Yeah.
parts out to them.
Wow, that's an interesting thought. It's like, yeah, you have 4-hour response on your data center, but you can't get 4-hour response for a ship in the middle of the ocean.
Right, right. Yeah, you're lucky if you can get internet connectivity on those things. So yeah.
Yeah, yeah. I mean, that's another thing to take into consideration is you may not have good internet connectivity, so you can't just replicate the data up to the cloud
Right.
and not worry about the local disks. That might be your only copy for a while.
hmm Exactly. Yep. So yeah, so we built a system that provides inherent data redundancy, inherent compute redundancy. It's all automatic. It's it's just part of the system, and as well as the autonomous operations. That, yeah, if it's in the middle of the ocean, a drive fails, there's no central brain that needs to make the decision to say, hey, this drive has failed, take it out of the storage capacity pool, regenerate mirror copies redundant of all the data on the surviving drives, and get back to full strength and just continue operating without disrupting the applications.
Okay. Well, I think it's time for another user poll. And this one, I'm really interested to see how people respond because I have my own ideas, but I'm curious what listeners, viewers think what's your biggest concern with the edge? Is it networking and connectivity? Is it security, application deployment, solution management, compliance and governance? And feel free to select as many as you think are top concerns. So maybe your top 2 or 3. Dave, when you look at this list, what do you think are going to be the top 2 or 3 out of the 5?
Well, yeah, I mean, security is a given, and it definitely is much harder in remote locations. So, I mean, that's a given. I mean, really, all of these. I mean, compliance and governance. A lot depends on the industry in particular. I mean, obviously, retail. You get into PCI and things like that. So that, I think, will be pretty industry specific, whether that goes to the top. But yeah, the deployment, the network and connectivity. Also kind of depends on the application. I mean, and sometimes having a very autonomous, highly available system like ours, it's like, okay, well, if the network's down, that's less of a concern. It's like in the end, I need my applications running autonomously. And like the example, the ship in the middle of the ocean, they're not worried about internet. They're worried about the applications keep running regardless of they expect their internet to be down and slow and disruptive and things like that. So
Mm-hmm.
it'll be interesting to see kind of what the audience responses are here.
Yeah, if I had to guess, and I'm purely theorizing here because the poll is still open at the moment, get your vote in. I think, yeah, security is like, that's the given, right? everybody's concerned about security, especially at the edge, depending on what kind of data you're pulling into those devices. For me, I think solution management, it would probably be my number two. Just how do I manage this solution remotely? Because that could be extremely difficult, and I want something that scales, and I want something that has some sort of automation built into it, because I don't want to manually go to every, location in my cluster and take care of it. So it looks like the poll just closed.
Yeah,
Let's see what the
you win.
results look
Good
like.
call.
So, all right, network and connectivity, we have 42%, security, 42%. So, ooh, yeah, security and network and connectivity right up there. Application deployment, 42%. Things are starting to look pretty evenly matched here. Maybe I picked the right five things to ask about. Solution management at 67%. So people are feeling pretty strong about that solution management.
You sold her
And
well. Yeah.
compliance and governance is down at 25%. And yeah, you know what? If you're not in a regulated market, then those other categories might be much more important to you. I'm a little surprised it wasn't higher, but I'm happy to see that my solution management went out.
Yeah.
And it also leads really well to the next couple topics. One is that, and this was, I put this in, and Dave, I think you even said to me, this is not necessarily an obvious category, but day two and beyond, it becomes really important. And it's like deployments should not require downtime. And that can be deployments of both your edge applications as well as the platform that your edge applications are running on. And, depending on your use case, you might not be able to afford downtime because you're in a situation where the application being down or the deployment being down is costing you, hundreds of thousands of dollars, or it's a critical service that could have real like life impacting problems if it's not up. So I'm curious what your perspective is on this, Dave. What have you seen, and how do you think about downtime when it comes to deployments?
Well, yeah, I mean, certainly, well, downtime overall, ongoing is really, the key focus of our solution. So the customers we talk to in general probably have already been burned by, yeah, we had this critical application and it was on a box and it went down and we thought, it'd be up in 4 hours and it was 2 days later. And so, all right, we're not going to do that again. We understand the need of for resiliency, automation, continuous application availability. Um, and sometimes even they've gone beyond that and say, well, okay, if it's not that, it's well, every time we need to update the infrastructure or deploy a new application, that requires reconfiguring things, taking things down, or we need to expand capacity, things like that. So when you look at it holistically, of all the different things that can impact downtime from the initial deployment, from deploying applications, from deploying new capacity. I need to increase my storage. I need to increase my compute for some new application, or even migration. I mean, that's one of the things uh, you know, that we provide is because we're based on a hyperconverged infrastructure, so we can run new applications and maybe containerize Kubernetes, all that good stuff. But we can also run the Windows 7 desktop that nobody wants to talk about, that still has to be there to run some application, to talk to some hardware that I mean that those things that everybody has, one or two of those things, we can run both of those, and we can even migrate them onto this now secure, easy to expand, highly available platform with little downtime. I mean, so we actually have tools that can kind of lift and shift those legacy applications, get them running on this secure, available platform. Really from kind of beginning to end, our goal is reducing downtime.
Right, and I think when you consider a data center, going back to our sort of traditional approach, you assume that the data center has a certain amount of resiliency and failover built into it. I mean, that's the whole point of having it. But
Mhm.
when you're at one of these edge locations, I know when I worked in retail, like we tended to have a server at a location, and if something happened to that server, hopefully the person got out in 4 hours to fix it if it was a hardware problem.
Right.
But
And hopefully had the right parts and all that. Yeah. It's like,
yeah, but they could be down and having to manually, write receipts and do the old slider with the credit card. I mean, I had to do that once or twice, and
yeah.
that's, customers will get fed up, they'll walk away, and that's just retail. I'm sure there's tons of other situations where it's actually much more critical that the
Right.
application goes down.
Yeah,
Is there
manufacturing line stops. I mean, all types of, all types of things like that. Yeah, and a lot of those are even 24 out, 24 by 7 by 365 applications where, retail has the theoretical advantage of, okay, most retail stores close, and so even things like planned downtime, maybe they have, some more opportunities, but trying to coordinate planned downtime and maintenance windows across, hundreds or thousands of stores and gets very complex, and ultimately something's going to go wrong there as well. So having that just inherent and handled by the platform is pretty critical.
Yeah, and I think that the key part there is your application might not have been designed with resiliency in mind. I mean, like the Windows 7 box that manages your lab equipment or something, or even Windows XP or something older. I've certainly seen that. That was not
I think we
designed with resiliency in mind. It
No, of course
was,
not. Yeah.
so your platform needs to bring the resiliency to that application.
Right. And yeah, and then you can, provide that same level of resiliency for any application, new or old, centrally manage them all the same way. Going back to the first point, simplify your environment, your infrastructure, fewer moving parts, fewer things to worry about, all that.
Sure, sure. And then, as your application evolves, then you can sort of turn your eye to how can I architect this application in a way that when I update it, it doesn't require downtime, or anything underneath it require me, taking the whole thing out of service just to, you mentioned adding capacity, and you would think like adding capacity is awesome. That shouldn't be a downtime kind of thing. That means more availability because I have more capacity. But I remember back in the old Windows days where even adding a additional hard drive, you had to restart the computer to expand a drive for
Yep.
additional capacity.
Yeah, and now that's just, with virtualization generally, that's, an easy thing to do. Yeah, and even, going back to the, that single server that used to be on the manufacturing floor or under the, retail manager's desk. You need to deploy some new application. They're certainly not going to open the case and throw in more CPU or RAM, and in many cases you just can't physically do that. So now you're either having multiple systems, which is generally how it goes. So you have the old PC and the new PC, or you rip and replace and try to expand that way. But yes, with virtualization, with the ability to not just scale individual workloads, virtual machines, but in a hyper-converged edge deployment like ours, actually add new capacity. I mean, if one of our customers is running on, let's say some very lightweight, entry-level Xeon CPUs, and has low storage requirements, in the tens of terabytes, whatever, and then all of a sudden, hey, we're going to deploy this new application. Now we need lots of CPU cores, lots of CPU cycles. We need 100 terabytes of storage. They can actually add nodes onto their existing single system, so they're not sprawling out their environment or adding things to management. They're just adding resources into their existing system. Those come online. Those resources are available, obviously, for the new applications, but even the existing applications now have access to that same common pool of highly managed, highly redundant resources just that easily.
Yeah, I think it's interesting. We take virtualization almost as a given when it comes to
Well,
the data center.
yeah,
Of course it's virtualized, but that's definitely not always going to be the case when you're looking at what's been deployed out to the edge over
right.
time. Ooh, all
Yep.
right. Well, that makes sense to me that deployment's not requiring downtime. I think it's time for our final poll. And this will lead into the next topic, but I'm really curious where audience are today in managing their infrastructure, whether that's within the data center, within the cloud, or, more holistically than that. So the poll just came up, and the question is, how are you managing your infrastructure today? Are you going through a manual configuration process where you kind of touch each node and switch and object in your environment and lovingly handcraft its configuration? Do you have a set of bash scripts and PowerShell scripts that you're firing off to configure your end devices? Have you moved into more of a configuration management software? Perhaps you're using something like Puppet or Chef or SCCM that actually goes out and does the configuration of your systems for you to make sure they're staying at within a certain level and you can detect drift. Or, at the more forward-looking or forward-leaning side of things, are you doing immutable deployments with infrastructure as code? You don't see a ton of that, but you do hear a lot of people talking about it. Or are you, your developers have hooked in, you're full on with the DevOps, and you got your infrastructure as code, it's going into a CI/CD pipeline, and out the other end pops, the configuration that automatically gets pushed to all of your devices. I mean, that's probably the nirvana. I'm guessing not a lot of people are going to be on that one. So, Dave, what do you think the audience in general is going to be at when it comes to infrastructure management?
Yeah, probably a good chunk in the first three there. I mean, I would say everything from some manual configurations to yeah, some simple scripting and maybe some level of centralized configuration management software. I mean, that's generally where we see existing customers. Now we do see, there's some organizations, some companies that kind of have the advantage of kind of greenfield deployment, and so they're at least looking at the infrastructure as code and the full application development pipeline. That's impossible to do with legacy legacy applications. If you've got that legacy stuff, then you maybe are doing a mix or looking towards a mix, and probably will have to continue that for a while. Uh, so
Yeah,
uh, yeah,
yeah,
so this,
it's interesting. Oh, okay. So far, it looks like almost everyone is at that configuration management software level. So when they're deploying out their nodes, they have some sort of configuration management software that's sitting on that back end pushing the config, and that's really good to hear because that's much better than going manually touching every single thing in your environment. Um, so that's interesting. I didn't expect that to be the case, but all right,
yeah.
good on everyone that's on the call. That's awesome. Um, that's the sort of thing that you probably also want to have in your edge computing environment. Our final one is that manual management it's really just a recipe for disaster. What do I mean by that? You might start off, and I know some people were, just dipping their toe in the water of an edge computing solution, and maybe they've got like a Raspberry Pi sitting on their desk that's, running a development version of an application or something, and that's completely feasible and usable from a testing out standpoint. But as you start to scale up your deployment, now maybe you've got a whole bunch of Raspberry Pis or something a little beefier, like an Intel NUC or something, sitting on your desk. It's getting a little harder to manage it. You want to bring in that configuration management. And then when you step up to having 10 locations or 100 locations, or Dave, I think you mentioned like 1,000 locations, manually managing that is just not an option. So how does automation play a part in edge computing?
Sure. Yeah, as we've discussed, I mean, automation ideally needs to be part of everything from that initial deployment to make sure that you can, rapidly deploy the infrastructure solution, deploy your applications on top of that. It needs to be part of, the lifecycle management, so day two operations of updating, infrastructure and applications, both just to adjust the scale, how many of these things that need to be done, but also to make sure that they're done right. At the infrastructure level, again, our starting point was basically delivering this highly available infrastructure as an appliance. So it's like think of it as an appliance where it is kind of a sealed system. It's designed to monitor itself, care and feed for itself, handle things automatically. That level of automation is built in. Nobody needs to go in manually and check drive temperatures, or check, hey, what are the error rates on this drive that's about to fail. That all has been automated away by the infrastructure, and as it turns out, actually is automated autonomously in each edge location. So that's not even a central repository that's got to gather all this, do central analytics. Each local system can autonomously check itself, see what's going on, take corrective actions, keep the applications up and running, and then as appropriate and as needed, feed that back to the central management location, to the central network operations center, or whatever kind of model that you're looking at. So both just in terms of keeping things up and running, keeping the applications going, and also updates. I mean, that's a key thing. So our system is designed to have a single click, or single call, single API push of infrastructure updates. So there's no, if you think of this, kind of the old traditional data center infrastructure or legacy, where, there's an update for my storage, my SAN, I got to go apply that. Oh, there's some software update for my hypervisor, I need to go apply that and make sure it works with the new SAN update and so forth. And there's my management tools, do they work with the new thing? We distribute and apply and update all of that essential edge infrastructure software stack as a single tested integrated unit, as opposed to a bunch of different pieces that you need to worry about updating, patching manually. And so that both makes it easier and less time consuming, but also just make sure that there's no errors, that you're not partially patched, or applying a patch for one layer of your infrastructure that's incompatible with the others.
Yeah, I'm just thinking about even in a traditional data center, I would often be patching the firmware on the servers, and then I had to update the virtualization software for the next stack up, and then above that have to patch the operating systems, and then finally you have the applications that live on that. That's a pretty complex beast.
Mm-hmm.
You're just trying to manage updates. So it's great if you can sort of wrap up at least a few of those layers together in a single update package. The other thing that I was thinking about when it comes to automation is integrating with either a policy engine, or integrating with some sort of CI/CD pipeline, or something along those lines to bring that level of automation to a DevOps type team. Have you seen something like that in the edge computing space where it does integrate with those types of solutions?
We have, and actually our systems can. I mean, that's an area where, as I would say, is still pretty new, pretty early, and somewhat custom. So there's not at this stage, I wouldn't say, one way of doing that fits all, but we do provide full API access. So any action that you need to take on an edge system, whether it's applying a policy setting, as you mentioned, whether it's deploying a new application, whether it's running a health check script that checks beyond the what the infrastructure is already doing. I want to check response time on this application at the local edge level and report that back. We do actually have an infrastructure that is all API driven, that can actually even utilize Ansible playbooks to kind of give you desired state configuration and check that every site, on some regular interval, every site, every application is, I mean, it basically is infrastructure as code at that point that is meeting its desired state setup, that everything is operating, and you can even use those on a scheduled or recurring or event-driven basis for as I mentioned, health checks to do further polling, response time measurements, things like that, that all are centrally managed and deployed.
Right. I want to pull out that Ansible comment because for me, that's awesome to be able to use Ansible to go out and apply a configuration to a whole set of nodes without having to individually touch each one or manage each one through a console. To me, that's a huge change. Um, for those customers that are taking advantage of something like Ansible playbooks,
Mhm.
what's their sort of process from creating a configuration change to actually rolling it out? Do they have like a dev environment, or so what's their process? I'm
Yeah,
curious.
that's where they're all a little bit different, but yeah, the generally what we would recommend is yeah, you either have you have a dev environment if you're making changes at that layer that would require them, that there's kind of a phased deployment, and we do provide a central management tool, what we call our Edge portal, that is where you both see have visibility to all of your edge environment, all of your remote locations, also where you would configure and launch and see results from these playbooks that are being run and distributed across the various edge locations. One of the things you can do, and we're actually generally this is done on a custom engagement because the workflows are a little bit different. We actually are working with some customers to develop playbooks that, for example, could do a health check, and once certain criteria are met, actually move that site from, say, a pre-deployment phase into a production phase from a management standpoint. So kind of actually
Hmm.
track the workflow, the life cycle of a particular site or even particular application, using Ansible and other orchestration facilities to kind of guide that whole process from beginning to end. And that could be used all the way to a full CI/CD pipeline, as you said as well.
Right. No, that's interesting. You need that feedback loop. So you mentioned the monitoring component,
Mhm.
which I think is sometimes it's something that people overlook when they're evaluating a solution is how it's monitored. You can get kind of dazzled by the speeds and the feeds and the fancy architectures and kind of what it can do on the ground. But if you can't monitor it, and especially in the case of edge computing, if you can't monitor it remotely and at scale, then you have no idea what's going on at your sites. You can't
Right.
react to it.
Yes. Yeah.
So, how have people sort of integrated their existing monitoring suite to encompass edge computing? Are they adding it to the solution they already have, or are they bringing in like net new solutions to perform that monitoring aspect?
Yeah, we've seen some of both, and I think this is where it's a little different organization by organization. It'll be interesting to see some of the things change over time. I mean, so in addition to all kind of the edge infrastructure, the HC3 Edge portal, and the things that we provide, we do provide all the other standard eventing, event notification, alerting mechanisms, syslog, things like that. So we do kind of now see, depending on the organization, where there's maybe dual responsibilities. So there might actually be someone who's, in charge of the edge remote infrastructure, but there's also a central corporate, data center management team that, may have their trouble ticketing system or, their own monitoring tools that also is getting critical events and alerts and, handing those off. So we're seeing kind of some hybrid stuff today, and that works fine for those organizations. They're already set up to be able to kind of handle that and hand off coordination between kind of the central IT department, and often there is a separate group that's responsible for, often they're called operations, for managing the IT operations remotely, for deploying people when there is a need to roll a truck with parts or physically deploy new sites, for example. So we're seeing kind of an interesting coordination of both. And we're trying to provide tools that actually meet both of those needs. Different views that are kind of operational focused versus service application focused, and provide the different views depending on what the user needs at that point.
Right, right. Yeah. So I would say if you're if you're evaluating solutions, make sure that it can fit into your existing workflow or provides a way to put together a better workflow if you don't already have something. And it sounds like you kind of have those bases covered. If an organization already has a ticketing workflow and a monitoring system, you can snap into that. If they
Yep.
don't have any of that stuff and they're at a different stage in their you know progression, now they can take advantage of some of the tools that you bring to the table.
Right, right. And we can even provide services along with our partners to kind of sit down and consult. Yeah, what are the operational workflows you have for site deployments? What are your maintenance schedules, things like that. I mean, for example, I mean we can and have the tools to do everything from full zero touch deployment, where stuff is pre-configured by our partners, shows up on your sites. basically somebody plugs it in, racks it cables, plugs it into the network, it phones home, gets all of its central policy, configures itself, runs the Ansible scripts to deploy its initial application, runs the Ansible health check script to determine, hey, this is ready to go live or ready to go to the next stage of deployment, notifies the appropriate people. But those, and then some people need and want that level of automation integration. Others, no, we actually want the gear to come to our central data center. We're going to pre-configure it there, load it, burn it in, whatever. Then we're going to shut it down, ship it out with somebody who shows up, actually hoist it up to the ceiling in the retail store. There's all kind of different processes that make sense for different organizations, and we have tools and services that are designed to support any of those that are required.
All right, awesome. Well, I think we have covered the automation angle quite well.
Right.
So those are our 4 points. At this time, I'd like to open up for Q&A and see if folks who have stayed on to the Q&A portion, do you have any questions for me, or more importantly, for Dave? He's the expert here. Let's see what has come up in the Q&A so far. All right, we have one, and it seems like it's kind of a broad question, and it's what type of hardware are you seeing at edge sites? So I guess they're kind of curious, is it all Raspberry Pis? Is it all 1U servers? What are you seeing actually being deployed in real life at these edge sites?
Yeah, so most of what we're seeing are clusters of short depth 1U servers in in telco boxes. So they're small, they're low power, they're enterprise grade. You can put a cluster. For example, one of our large retail deployments, we actually work with a partner to pre-integrate. And there's case studies actually on this, so I can mention Delhaize. Ahold Delhaize is a large grocery store chain based out of Belgium. They actually deploy, and they've what they call internally the one box, which is a small rack with 3 compute nodes built in. These are actually powered by Lenovo 1U servers. The switching, UPS, all pre-cabled. They basically roll them into a store. As I mentioned before, hook up the power of the network, hoist them up to the ceiling, and then deploy the applications. And they can do multiple stores a day. Deploying that way. There's no, racking, stacking, cabling, no operating system to install. Very, very streamlined. So we're definitely seeing a lot of that. Most organizations can find the appropriate room for, one of these kinds of telco box, short racks, things like that. Other cases from a cost standpoint or real estate standpoint, we did just recently release our HE150 series, which is our small form factor, or sometimes we call them nano nodes or micro data centers. These are very, very small devices. I'm working from home as everybody is. I happen to have 6 of these sitting in my office that I'm looking at, two clusters of them that are I'm running SQL Server databases and running HammerDB and actually running VDI on these things. And if I pull the power out of one, the applications just keep running and fail over to the resources on the other. But that particular system, you can deploy a 3-node highly available system, redundant storage, automated compute failover for $5,000 ish, depending on the capacity. So about what you'd spend on one beefy server by the time you throw RAID cards in and RAID redundancy and redundant networking and all that. You can have full redundancy, the ability to do rolling upgrades, infrastructure. So that's something we recently introduced to really actually kind of address, even at a price point of people's like, well, we just have enough money to buy one server and we're going to roll the dice. Well, what if you for about that can get more compute resources, more resiliency, more storage in a system that has full automation, redundancy, rolling upgrades, and is expandable even. So, if you start with, 3 of these HE150 nodes, and now you need more capacity, you can add more on and grow your system. When 3 years from now, systems come out, with Moore's law that are, half as much and twice as fast, you can, without even, basically add those on to your existing system. And then eventually when your current nodes meet the end of their useful life, you just can kick those out of the cluster. So you can also avoid kind of this future forklift upgrade treadmill of, constantly re-architecting and actually have a permanent, edge architectural solution. So we're seeing a wide range of hardware, but yeah, generally, smaller form factors, using, cheaper, less expensive devices, smaller capacities, clustered together, as opposed to, big monolithic servers that, you're just waiting for something to fail and hoping you can get somebody to come fix it in 4 hours.
Yeah. All right. So we have another question, and ooh, this one is interesting. How do you judge the advent of AWS Outposts and Microsoft Mech, which I think they might be referring to the Azure Stack Hub solution?
Okay.
Have you seen them starting to take market share in the edge computing space?
I'm sure there are use cases where those make sense for probably net new applications, 100% cloud native applications, and with the ability, obviously the respective integration with the public cloud facing IoT solutions, things like that. So I'm sure they have a place in the market. We also are seeing customers who want to basically run the software versions of those as virtual machines alongside legacy applications that they have. And that's really been our focus in the market is, seeing those. And I do think, for cloud native applications, for IoT centric applications, edge gateways, things like that. There's going to be cases where, yeah, a dedicated cheap device, I don't need redundancy. That's, just pop one of those out and go. In other cases where there's a more complex environment, legacy workloads, multiple workloads, they need to be able to scale out. That's where I think infrastructures like ours are going to make more sense.
Yeah, and it's a little confusing when it comes to what AWS has out there and what Microsoft has out there, because
Mhm.
Microsoft just went through a huge rebranding process. It's like, oh, which Azure Stack thing do I want?
Yeah.
Because there's I think four now. And Outpost is one solution, but then there's also Snowball and Snowball at the Edge, and there's Greengrass. So
Right. Right.
it's a nuanced kind of market. But yeah, I guess you have to look at your business use case and then see if what they offer in that space matches what you want to do.
Yep.
Um, I think we have time for two more questions. One is, how do you get edge sites connected together and connected to the cloud? So I guess this is around the network connectivity question. What have you seen anybody try to mesh sites together, or just like deal with that connectivity to the cloud?
We have not. Well, I would say generally no. I mean, although most of the edge locations we're seeing, they have their own internal networking already set up, whether it's MPLS or things like that. So they have some level of connectivity in place already. I guess I would say we've seen some use cases. Retail is what I'm thinking of, where maybe small data sets, like, okay, we'll have this store back up some transient data, configuration data, to another site. Although usually those come up in the sense of, well, that's how we used to do it when we didn't have redundancy, and we hope that those were backed up over there. So I guess, yeah, we've probably provided better ways of not needing, those kinds of, site to site things. Um, but yeah, I mean, like I did mention earlier, we do see many organizations that do look at this as an opportunity to do a network upgrade generally from a security standpoint being a driver. So, whether it's, looking at, virtual appliances, enhanced firewalls, software-defined networking kind of things. We definitely expect to see more and more of that. And we, back in the fall, did a presentation of some new capabilities that'll be coming out over really the next year, that we call HC3 Edge Fabric, which is just more advanced networking, plumbing built into the HC3 stack, both to improve the ways you can connect these edge systems together. For example, one of the things we demonstrated was taking some low-end devices and networking them to each other from the cluster standpoint using Thunderbolt connections, and then the LAN ports, connect out to the world and so forth. But having some interesting things like that are available with this HC3 Edge Fabric networking. So we do see people looking at addressing the networking, looking at certainly securing the network if that's something that has not already been done, and also people that are viewing networking. A lot of organizations still have, will continue to have their own separate network teams, but we are seeing more and more in these edge deployments where they're considering network as just part of the edge deployment and infrastructure, and designing that, as they pick their infrastructure stack, as they, pick their storage and virtualization technologies, ensuring that those include the appropriate networking capabilities. And we have all the network isolation things that you'd expect already today, like VLAN support and things like that, that can support that.
All right. Well, I would love to dig more into the networking thing, but we have reached the end of our time. I want to say thank you so much to Dave Demlow from Scale Computing. Thank you for joining me today.
Yes, thanks. Thanks for having me, and thanks everyone for joining.
Yes, thank you everyone for joining. I hope you have an enjoyable remainder of your day, and that will end the webinar.